this and inviting me. And thanks to Raj for pulling me into this. I'm glad to share whatever I know. Hope it will be helpful for you all. So let me share my screen. I'll try to make it less boring. Can you give me sharing permission?
Yes.
I know there are many, it seems like there are many faculty along with the students are also part of this event. So faculty may know many of this already. But I just want to give some brief introduction to, so since the topic of today is 5G, so let's briefly understand what is 5G, and then we'll quickly see how it is being implemented in the industry, and then how you would want to think about 5G and adapt it to your career. So we'll quickly see what is 5G, and then what are the requirements, and how do you define 5G, and who decides 5G, which is the 5G standardization process, and how has it been penetrating into various markets, and then what are the current use cases for 5G. So the definition of 5G. So you guys may have already heard about 4G or LTE, as it's called in India. There are many names to it, like LTE Advanced. The next version of LTE is LTE Advanced, and there is LTE-U, which is LTE Unlicensed. And oh, by the way, before I kind of get started with this, just to get a little bit of background, are all the students from a bachelor's? Hello?
Yes, sir.
Okay, so all the students are from bachelor's, as in BTech?
Yes, sir. All the students are bachelor's.
Okay. So remembering from my ECE days, you must be probably studying about modulation techniques and probably the sampling rates and some of those other things like the filters and RF components, and probably the most complicated subject of it, like antenna wave propagation and electromagnetic wave theory and so on. So although they seem complicated at this moment, please pay attention to those classes, because those are some of the fundamental building blocks of how these technologies are built. So for example, so if you take the key enablers of 5G, they are called, like, these are some of the key enablers that are enabling the 5G to come into existence, right? So that's spectrum efficiency. So for example, how much or how many devices you can connect using the spectrum that's allocated to you. So what's a spectrum? Basically, a spectrum is a frequency band that's assigned for the communication standard. So for example, Wi-Fi. I think most of you use Wi-Fi today at your homes, or Bluetooth for that matter. And they both have dedicated spectrum allocated, although that's unlicensed spectrum, which is 2.4 gigahertz. And anybody, even you guys, can build a device that can communicate in 2.4 gigahertz without being penalized for it. But in the telecommunications side, spectrum is like a real estate. Telecom companies buy spectrum. So for example, 5G, you might have seen in many of the mobile, when you buy a mobile phone, you see. Sorry, somebody's saying something?
No, sir, we can continue.
Okay. So when you hear the word spectrum, it's kind of a real estate, right? So for example, when you buy a mobile phone, you would have seen in one of the specifications of any mobile phone, like, it supports 1800 megahertz, it supports 2100 megahertz, or it supports 1800 megahertz. those are all the real estate parameters. For example, if you take the enlargers of real estate, so 1800 megahertz is kind of allocated for GSM, and then 1900 or 1800 to 2100 is allocated for LTE. So for example, for this standard, you are allocating this band of frequency, and even within that band, each carrier buys certain band. Okay, I buy this portion of that available band to me. So Wi-Fi cannot use it. Bluetooth cannot use it. Only telecommunication companies can use it. Even that, only the company that bought this frequency can use that frequency in communicating with your mobile device. So that's what spectrum is. But how do you do it? Like in terms of like I told you in the beginning, electromagnetic wave theory or antenna wave propagation or some of the filters that you must be reading through would help you filter that frequency, understand the frequency, demodulate it, and decode it, and understand what the message was. How effectively you can use that real estate, how many devices you can connect within that frequency is what spectrum efficiency means. So there are multiple ways you can do it. So you must have also seen 2x2 MIMO, 4x4 MIMO, 16x16 MIMO, and so on and so forth. So as in the base stations, if you see, for example, I know this image is fairly small, but there are multiple base stations that you guys must have seen when you simply walk on the road. And you see different antennas that are connected on 4 sides of the base station. So those are like the amount of antennas that are trying to communicate, and they can reuse the frequency, and they can probably sectorize the cell and then only communicate in that cell using the repetitive frequency. So that's what spectrum efficiency is. Like, how do you make the spectrum more efficient or communicate with more people? So again, to simplify it, like I'm guessing that you guys are understanding it. I'm just trying to simplify it even further. So for example, you have a bunch of animals, and each animal is shouting at other animal, and there are 2 humans also who are trying to talk to each other. Probably most of you can communicate because all of them are different sounds. So you are still able to communicate in that room. But if there are 100 people that are trying to speak with each other, that may that may not be true, because everyone speaks at the same, probably same language, same voice, same modulation. So it might make it harder for you to hear each other because there are 100 people that are trying to use the same voice frequency. So that's what spectrum efficiency is. And how is it doing it? So there is a concept called massive MIMO. So right now, earlier I mentioned about 4x4, 8x8 MIMO. And massive MIMO is like bunch of antennas. There is no probable definition to it. People call it 100 antennas at the base station. It could be much more antennas at the base station. But basically what it means is like massive number of MIMO antennas that will help you send communication to different mobile devices using the same frequency. And that was not there in LTE. And this also enables full duplex communication. So right now, if you have a channel that's sending information, and that channel need to become vacant for it to receive information also. But right now with massive MIMO, you can probably use same channel for sending and receiving, because different antennas would be doing that for you. So you can do full duplex communication at the same time, which obviously increases bandwidth. So for example, if I want to talk to you, you ask me what is 1 + 1, and I need to wait for you to complete the 1 + 1 and 2 + 2 question. But if I can respond at the same time, as you said 1 + 1, I'll say 2. By the time you can tell me 2 + 2, and I can tell you 4. So there's parallel communication happening. So I don't need to wait for you to finish all your questions. I can in parallel answer them. So that way you can also effectively use the spectrum. And densification, this enables more devices. So for example, again, some of you, at least few of you might have faced situation where, oh, all lines are busy when you're trying to reach out to someone. Or you stop getting data at some point. So in both situations, what it basically means, loosely associated, is there is no resource available for your device to communicate to the internet or to the other person. So, but with this spectrum, you have more resources, so you can still be able to communicate with the network, because it'll allow more devices to connect with using the same spectrum, or having the ability to communicate more. Then you have other concepts like, so these are all the device side. Some of them are device side, and there are some of them are network side. So software defined network functional virtualization. These are all the software concepts, like AWS kind of concepts, where you're trying to define the network on the software side. And network functional virtualization is literally virtualizing the network. So again, just going back, you have these bigger base stations that I told you before. Each of those base stations used to have, at least, I think you might still find them, have a big container sitting next to the antenna. So that container contains the processing power needed, contains dedicated processor chips, hardware, software, and ports, and all of that functions in that big box, which also would have been connected to a generator or a transformer for it to power. Right now, with the network functional virtualization, SD-RAN, and concepts like Cloud RAN, as you guys transition to 5G, what they are doing is they're trying to make that box go away. You just have the RF module, which is the antenna, and then you have fiber optics or backhaul connected to a centralized server, which could be your PC itself, that does the processing for you. So there are certain such concepts that are enabling the flexibility of network as well, in addition to improving all the other things that I mentioned to you. So this will also enable you more devices to connect, which is massive connectivity. So now coming back to the definition of 5G. 5G is simply a next iteration of the cellular standard, but it will bring in all these types of features for your devices to connect to the network. So the requirements. So who decides the requirements? So there are multiple standard organizations that will kind of decide the requirements for 5G. So there are certain requirements like data rate. Like what is the minimum data rate that I need to hit to be called as 5G? Then there are standard requirements like, I want 20 gigabits per second, which are theoretical limits. And then within the theoretical limit, I have like, the theoretical limit can still be achieved if there is only one user in the cell, but there could be like 1,000 users, 2,000 users in the cell that are trying to communicate to the network at the same time. So then what's the user experience limit? It could be 100 Mbps downlink and 10 Mbps uplink, so on. And then spectrum efficiency, like how many devices and how many bits can be transferred at the same time, and what's the capacity, latency, and so on and so forth. So these are defined by IMT 2020. You can actually go and check, try to look for it in Google, and you will be able to find the IMT 2020 who is trying to set these requirements. Then what's the core architecture? And again, I'm assuming here that most of you would have read handovers, cell area, cell coverage, antennas types, MIMO, modulation, those kind of techniques. So I'll just don't repeat any of those. I'll just go to the system architecture. Basically, you have a macro cells for 4G or 5G. You can probably see, even it's a small image. It kind of tries to depict there are 4 or 3 antennas for 4G, but you have a bunch of antennas. These are all small antennas that are trying to do the beam narrowing or beam steering or beam positioning to only communicate the beam with the user. So right now you have omnidirectional antennas, or you have different types of antennas. Like omnidirectionally, the signal gets transmitted in all directions. But this beam steering and beam forming is a concept where for example, you are in this car. I guess you guys can see this. So let's say you are in this car and you're trying to go on this road, and this particular base station can actually reuse the frequency that it's using to communicate with this other car. But since you are here, it can use this number of antennas and position the beam in such a way that the same frequency can be used to communicate with you. And the same frequency can also be used to communicate with this other person without having an interference, because it's highly focused. So basically, the system architecture contains many of the cloudification aspects. So all these RANs, RAN as in a base station. So in the industrial setting, people less likely call it as a base station. Either they call it as a cell or they call it as a RAN equipment, radio access network equipment. So all these RAN equipments are connected to the cloud, which are controlling the policy aspects and the handover aspects, and then letting the user connect to the network, and all those activities are being taken care of in the cloud. So this is where you are removing that big box sitting next to the antenna. And then these are some of the concepts that are being implemented, and this would enable a millimeter wave, higher coverage, and something like URLLC, which I'll explain in the later slides. So basically, what did we cover? What's 5G? 5G is immediately the next generation technology, but which has groundbreaking inventions that's letting you do more things than what was possible in 4G. And then the system architecture basically is changing, where you are trying to cloudify everything, and you also have situation with things like Cloud RAN or flexible RAN, massive MIMO, network slicing, NFV. These are some of the technologies. You can read them up online. I don't want to take too much time explaining these, but those are some of the key elements that are also improving the network layer to make 5G possible. So, but where are we? Like we are talking about all these requirements, all these theoretical limits, but who decides or how it's being developed, or who tells everyone what to do? So there is an organization called 3GPP, Third Generation Partnership Project, and if all of you are communication engineers or want to be a communication engineer, please do remember this particular standard. This is highly important and highly industry relevant. So most of what we study in our academics could still be theoretical, or could probably be already outdated in terms of technology, but it's still important because that gives you the building blocks to understand everything that builds on top of it. But to make yourself relevant to the current status of the industry, 3GPP is the website to follow. Although it's confusing website, but if you play around, you will probably understand what it is. So these are the guys who set it up. So what happens in 3GPP? For example, I'm Samsung, Samsung, Nokia, Qualcomm, a bunch of these companies who actually drive this standard. They get together in different parts of the world every month. 1 month in India, 1 month in China, 1 month in Europe, and so on and so forth. So they go to these meetings and they say, okay, our requirement is to hit 100 gigabits. I'm just saying hypothetically, 100 gigabits is my requirement. So what should we do to get to 100 gigabits? So do we have more spectrum? No, we don't have more spectrum. So what can we do within the spectrum that we have? Oh, I propose we increase number of antennas. And then say, should we increase number of antennas to 100? Should we increase number of antennas to 200? So every company comes up with different proposals on how to increase the antennas, or how to use these antennas without having interference between them. Because if you place two antennas super close to each other, you know, the sampling frequency, right? Like if the frequency disperse between the antennas, then the interference will be high between these two antennas. So I'll come to that later, but that's how people find, oh, in order for us to achieve this, there are all these problems that we need to solve. Now all of you go home as in go to your companies and then start solving them. And then coming to the next month or next month or next month, they come back and they say, oh, for that problem, we found this solution. And then Nokia might come and say, I have found this other solution for the same problem. And then they decide, oh, this solution seems to be more appropriate and easily implementable and low cost or whatever. And then everybody say, I agree. And then that particular solution gets adapted to the standard, which we call 5G. But 5G is not just 5G. 5G has many releases. So really until release 14, it started with release 99, and release 8 onwards is what we call LTE, and release 8 to release 14, everything in between is what we call LTE today. And from release 15 and beyond is what we are calling 5G. Although the marketed term is 5G, it has bunch of releases that keeps ongoing. So the 5G that you would have gotten in 2019 is different from 5G you would get in 2022, because it would have gone through multiple iterations and multiple improvements in terms of how they implement various features and so on. So release 15 is what it started with, and initially people called it as non-standalone. So when you say non-standalone, you are still using a 4G antenna in combination with a 5G antenna, and not antenna. So 5G base station, 4G base station, but you have 4G network controlling these two. That's called non-standalone. Then later stages, we have standalone. Standalone meaning there is no 4G component at all in the network path. So if you imagine a network, so you have a mobile phone, you have a base station, and then you have a core network. So if you think these three are the key elements to the network, in all these three elements, if everything is 5G, then it's called standalone. But if there is a 4G component in either base at the core network, then it's called non-standalone. So then release 15 happened, then release 16 happened. For each release, they propose certain features, and if they finalize certain features, it's basically software, right? Like you have version 1, version 2, version 3, version 4. That's how 5G version 1, version 2, version 3, you can probably think it that way. Right now, we are in release 18. This is like a year-old chart. Right now, we are in release 18. So they have like, okay, what we want to finalize in release 18. Okay, then we develop it. Then we freeze it, then we go through multiple corrections to it, and then we finalize the release. And then during this development, that's when companies starts adapting those features and start deploying in their chips. So that's why you see the 5G before different from 5G now. So that's who decides the standard development. But what's going on, like who are trying it out right now? So I think India is expected to, a few years back, India was expected to get 5G. I think you may already started seeing a little bit of here and there. I think it'll fully be deployed probably this year or next year. That's the prediction at least. And the US, I think every device, or almost all the devices that are being deployed today are 5G enabled. And all the networks, I think, already adapted to the 5G, especially T-Mobile, Verizon, AT&T, the big networks, at least, they're fully 5G right now. Almost all the entire world is expected to transition to 5G by 2025. Then these are some of the operators in different countries that are leading the 5G transition. I don't think we need to go through that. Then, yeah, like in the US, these are some of the operators, Europe, the operators, and so on and so forth. And like in the system that I mentioned to you before, you have the mobile, you have the network, and you have the core network. So these are all the network piece, the core network guys. These are also control the RAN part, as in the base station part, but base station needs a hardware. So these guys provide you the hardware that's needed to run the base station. And some of these guys would also help you run it, but they also help you with the core network as well. And device side, you already know Qualcomm is one of the key companies that build modems that go into all of our mobile devices. Then MediaTek is the other company that also builds modems that go into many of our mobile devices. These are kind of the two key companies that go into almost every mobile device like that we use today, even that's in your pocket. But there are a bunch of other companies that also develop modems, again, based on technologies that Qualcomm, Nokia, Ericsson, all of these propose. Like there is Sierra Wireless that helps with the IoT chipsets, and there is U-Blocks. Like there are some small companies or some companies like that help with various types of other devices, like connected cameras or connected sensors or connected robots and so on and so forth. But primarily on the smartphone side, those are the two key companies that has like majority of the market share, like the Qualcomm and then the MediaTek. I think Huawei used to have its own modem as well. Now I think the high silicon or Huawei phones that you see, I think they would probably have their own modem as well. So what are the key use cases? So when 3GPP decided to build 5G, they had thought of three verticals. So one is enhanced mobile broadband, massive connectivity, and ultra reliable low latency. The 3GPP always comes up with funny acronyms, and there are a bunch of acronyms. If you even open 3GPP even once, which you don't get exposed to during your bachelor's or your EDC or some of those courses. But if you go to 3GPP website, you see like this is written as EMBB, this is written as like MTC, or this is written as URLLC, and like CSI, a bunch of acronyms. Like they use many acronyms to define, so don't get confused or don't get discouraged when you see an acronym that you don't understand. That's how everybody feels like, unless you have been reading it from like past 5 years or 10 years. So just pay a little more time, like spend a little more time, understand what the acronym means, and you would find it easily. So basically, these are the use cases, use case verticals. So enhanced mobile broadband, as the name says, that it's basically high data transfer kind of use cases. So when you have high data transfer needs like Netflix or Disney Plus or Hotstar, or like any of those kind of use cases, you need higher data to be transferred. So any use case that contains that involves higher data transfer is called EMBB use case. And that's basically like at any speeds. Like the 3GPP also defines at what speed you are traveling and what could be the data transfer rate that can be supported at that speed. So for example, if you're traveling even the bullet train, you should still be able to stream YouTube without buffering, which you cannot do with Wi-Fi. Like Wi-Fi is primarily a stable connection within the vicinity of your space because of various restrictions that it has with the spectrum. So then massive connectivity. Massive connectivity, as the name says again, connecting exponentially more number of devices than what we have today. So some of the surveys that says that, like, I think 4 or 5 years back, each home having one connected device, which is primarily the mobile device, was kind of the norm, or maybe two mobile devices. Right now, I think every person has at least one mobile device or at least two SIMs in one mobile device. So I think right now each household seems to have minimum 4 to 5 mobile devices, and that's on the smartphone side. Then you may have a smart speaker, you may have a connected watch and connected glasses or whatever it is. Like, so now right now the number of devices that one would expect to have is probably 30 or 20 at least in the rest of the world. May not be in India, but at least like 20-30 devices are expected to be connected in each house. And that could probably become 100 in each household in the next couple of years or so, because you would have connected thermostats, connected electric meters connected, water meters, and some of which are you probably connected to cellular, some of which may be connected to Wi-Fi, and so on and so forth. So a network that can enable or a use case that needs such connectivity is called massive connectivity. And then the other use case or other use case vertical is ultra reliable low latency. Again, as the name suggests, so for example, you might have heard of the sci-fi kind of use cases. Just give me 1 second. Okay. So the sci-fi kind of use cases where the remote surgeries, remote surgeries where a doctor sitting in the US or a doctor sitting in India can perform an operation to a patient in the US or elsewhere in the world. And for that to happen, if a doctor wants to cut a tissue at some part, doctor should not be basically waiting. Like if it does this motion, it should, in fraction of milliseconds, that same motion should happen at the robot side as well. But if the doctor does this and just keeps waiting for it to buffer, then it's highly unlikely that him performing an operation. So that's the low latency communication. And what's reliability? So for example, if doctor does this, and let's say, for example, this movement has 50 kilobits of information for this movement to happen on the other side. But let's say if 3-4 bits are flipped because the connection was not reliable enough and there was noise in it. And if the doctor does this here, but if on the other side, thousands of miles away, if the movement is like this, then the operation is already failed. So I'm just giving you a random use case, but generally speaking, that's what the reliability and low latency part comes in. But this has many other use cases, not just remote surgery, but also, the emergency response or AR/VR use cases where, let's say, you are interacting with a person like thousands of miles away, and how quickly you get the feedback from the person, and like industrial automation where you have robots running around in the manufacturing facility, I think, which is also part of the topic today. So which is automation, 5G in automation. So that's one of the use cases that will help you enable that industrial automation, the robots moving around in the manufacturing facility or a warehouse facility without dropping any frame or any bit, or with having low latency communication that will enable them to move around freely and perform all the activities that a human would. So summarizing all these three verticals, so enhanced mobile broadband, massive connectivity, ultra reliable latency. So there are three types of interactions, right? Like human to human communication, human to machine communication, and machine to machine communication. And this is another key vertical or cross intersection that will be enabled by 5G type technologies or newer Wi-Fi type technologies, and which is crucially important. And this is what people calling as industry 4.0. Like we are in the next industrial revolution where machines just perform tasks on their own and produce the goods needed. So if you see some examples, like human to human, in any AR/VR situation, human can talk to a machine, or human can talk to other humans, sitting elsewhere in the world, or even different, elsewhere in the world. And virtual meeting, video calls, and wearable social networking, emergency calls, these are all human to human interactions. Human to machine interactions, I think you have seen many videos where industrial experts sit together and try to, design an engine of any vehicle, and then they all sit together in different parts of the world, but they would be able to see the same exact design as others modified. So they are interacting with the mission, but which is also communicating to the other humans, but basically they're interacting with the mission, which is a remote surgery also part of it. Like a robot is, a doctor is trying to interact with a robot sitting thousands of miles away. And then there's another key use case, which I'll explain, the vehicle to pedestrian, which is interesting use case, which I'll explain later. And the mission to mission communication, where just if you have a temperature sensor and the temperature drops in your warehouse, and temperature sensor just simply tells the air conditioning unit, so the temperature dropped, can you increase the air conditioning? And then the air conditioning can work on its own, basically without having human to look the temperature reading and then go and set the air conditioning in the facility and so on and so forth. That's a simple use case, but that's what Industry 4.0 is, where all the sensors communicate with each other or communicate with a centralized intelligence system that determines what needs to be done based on the information that it gets. So those are key applications. Which like if you take this triangle, which is an interesting triangle, the LTE kind of enabled the basic IoT communication and little bit of V2X. So the V2X is the vehicle to everything. X is everything. X can be a variable, so that's why X is everything. With LTE, I think right now the vehicles that are being launched in India are here in the US. They are able to communicate and lively download maps to the car itself, where earlier days, I think some of you may know, especially the faculty and people of my generation would know, that like if a vehicle needs to have maps, you either need to plug in a USB drive or a memory card into the vehicle, and then the maps gets updated. But right now, like all the maps and everything are primarily connected, and then you can just download the map, or map gets dynamically rendered as you go. It's basically happening because you have a LTE modem in the car that's using the existing telecom network, either Airtel or Idea or whoever, and then trying to communicate to the server and download the map. So that's the primary use case at LTE. But as you move on to the 5G kind of use cases, then you have much more kind of use cases coming in. So that's what this is trying to depict, like the advanced V2X, which I'll show you. I have a separate slide for it. I think it's interesting slide. So generally speaking, some of the key industries that will be impacted, like autonomous driving, wearables, AR, VR, I think we kind of have seen some of these. Then yeah, it will bring you, it will help you do network slicing, the concept that we spoke earlier. Basically what this concept is, I think you might want to read up on this. Right now, let's say you have a processor and you have a processor, and it's trying to pass on packets coming from the end devices. So let's assume these are all end devices, and it's sending you packets, and the network is trying to determine or allocating same resource, which is the processor itself, and processing these packets and then sending them to wherever it needs to send to. But the concept of network slicing basically is, each task that's coming in, or each packet that's coming in, or each device that's communicating may not need equal type of resource. So then you try to break it. Like I have a massive IoT layer where you might only have few bits, like all the IoT devices only transfer few bits, like I'm on, I'm off, my temperature is 10 degrees, 12 degrees, 30 degrees. So that's very minimal information coming from these. So if you have a separate layer to process those, it's fairly easy. So I think, again, to compare it with something that you may be probably aware of, you must also be doing electronic circuits, or STLD. That's what it was called anyway when I read it. So I think in that there is a concept called, full adders, half adders, and multiple adders, and so on and so forth. You can implement a full adder, half adder using bunch of logic gates, and you can create a logic gate every time. Or you can actually create a combination of logic gates just to perform multiplication and keep that hardware in a processor. Every time you just feed inputs and it will give you output. So you don't need to dynamically link all the logic gates on the fly to get to the answer. You already have a predefined multiplier or adder defined in the processor. So those are called cores. Sometimes in the GPU sense, they are called cores, but core is a little bigger, but I'm just simplifying it. So, but they have a dedicated purpose. I just do multiplication, nothing else. Like my logic gates only help me perform multiplication. So likewise, you can have multiple layers. That's what a slice means. You have different slices with different resource allocation, and each slice has a dedicated purpose. So anything on the low latency side, let me take it up. I'll try to push it quickly so that I can achieve the low latency needed, and likewise for others. So that's what the network slicing concept is. The interesting part. So the V2X, right? Like vehicle to everything. So in 4G, you have, like I said, primarily for multimedia or infotainment purposes. But what it could actually enable is a car to talk to other car. I think we have kind of probably imagined it would happen, but 5G is what would make it happen in reality. So 5G has this concept called device-to-device communication. It's been in the works for a while, but I think 5G will probably help push it forward. It's called side link, where basically a car can directly communicate with other car without having the network in the middle, or it could also use the network in the middle if need be. So since it can talk to other car, it also knows where the other car is, what the other car is seeing, which is extended sensor. So for example, the car in front of you saw some obstacle, and it will tell the cars behind it that I see an obstacle 200 meters away. Although these things cannot see that obstacle, but they know that there is an obstacle coming, and they kind of react to it before the obstacle even comes. So that kind of makes the car a lot more safer. And vehicle platooning, like you have one human driver trying to drive a vehicle, and there is a platoon, as in bunch of vehicles that follows the initial vehicle. It's like a train where a vehicle train, if you will, only the front vehicle would have the driver, which is the engine bogie, and all the other bogies would just follow. And then remote driving, you sit at your home and make your vehicle drive, because you have all the information from all the sensors and like video live streaming without any latency, any delay, and like you just play a video game and the car, you are actually driving a car. So these are all the possibilities with 5G and the vehicle space. I think you being highly connected generation must have seen the efforts that are happening in the automotive vehicle space. Although the current automotive vehicle, I think there is some attempts of doing this. There is a company called Faction that I know that's trying to do this. And there are a bunch of companies, like, for example, Qualcomm is trying to do this, and then some of the other companies are also trying to implement this one in their level 3, level 4, level 5 autonomous systems. So this is a pattern picture, like which are the key companies working in this space. I think you can see it later, which is not super important. I don't know how we are doing on the time, guys. How are we doing on the time? Do I have a little more
We
time?
have 15 more minutes, Sandeep.
Okay, awesome. So healthcare is another key interesting area. That like in any hospital, there are a bunch of sensors that needs to function, even the sensors that you wear, like Apple Watch or any of the other watches that you wear, and that are expected to be highly beneficial with this connectivity in a factor that's going to bring in to the picture. So healthcare is going to take a huge leap in terms of how it solves. So I know a company called ResMed. It's called respiratory medicine. Basically, many people snore. I think I do snore as well. But what this company does is, like, it's again just an example, not to highlight the company, but highlight the use case. So you can also have the user connect the device to a Wi-Fi network, but Wi-Fi networks are not reliable. Like, the control of the Wi-Fi network is with the user. So if the end provider meaning doctor or hospital, wants to see your vitals or your sleeping patterns, it all depends on how well user maintains his or her Wi-Fi network. But that's where companies are trying to eliminate the user layer. Like, I give you a device, and then I can monitor everything I want from you and recommend what is needed. So that's where the 5G element is creeping in, where companies are trying to build devices that are directly connected to the cellular network, so they can directly monitor data whenever they want without having you in between, trying to set up the Wi-Fi network, enter the SSID password, and then 10 devices and Wi-Fi failing or Wi-Fi not being connected properly and all those things. So that's where the health use cases are coming in. Right now, this is one company that I have actually seen in person, where they have this device that's already pre-planned, and like they would have baked in the cost of the network charges also into the device cost, and you just buy the device, use it at your home, and it connects to the network and it uploads the data. Like, okay, this person is breathing heavily at this particular hour in this particular position, or he's sleeping highly between this time frame. And and what this device basically does is, as it notices you trying to breathe heavily, it pushes oxygen through your whatever the mask that you wear. So because you get more oxygen, you stop snoring. Like basically, snoring is kind of an attempt to breathe in more oxygen or breathe in more air, and then it tries to push more oxygen with the mask, and you kind of stop snoring or sleep better. So that those are kind of the use cases for 5G on the healthcare side. And again, automation side, this is another important topic for you guys. On the automation side, all the robots that are connected, that are performing these highly fraction of second operations, like trying to produce everything that we use today, for them to function effectively, I think that's also, you need those low latency connection, and that's where the industrial automation creeps in, and 5G kind of would probably enable that as well. So not just to say again, you guys would be getting into the industry soon and trying to find or help this industry grow as well. So although I'm talking about 5G because the context is 5G, there may be Wi-Fi like advancements also that may take up some of this market share, but 5G will have its own place and Wi-Fi will have its own place there. So then on the retail side, like you have all the armaments, clothes and goods and everything located. If you have a small 5G chip in each of the shelf or each of the item, you can track the item from the manufacturing facility to the sale point of sale, and then everything can happen seamlessly. Those are kind of the use cases that are being thought of in the supply chain management or in-store experiences, or analytics, like how many people are trying to buy the product, and where it's located, how many are gone and how many more need to happen, and so on and so forth. And AR/VR, I think we already spoke of this one. And then standard bodies, I think initially I spoke of 3GPP, but there are other standard bodies that also help move the standard efforts forward. But primarily, I think I would advise you to take a look at 3GPP if you're really interested to know what's going on there. Although it looks super confusing, you can also follow up some of the videos to understand the simplified version of what they're saying. And then there is ITU, there is ETSI, there is GSMA, and there's some of the other ones that also have some say in what goes into 5G. So finally, I'm trying to close this little quickly, so I'll give 5 to 10 minutes time for you guys to ask any questions. So finally, what I want you guys to take home is, whenever you think of solving a problem or trying to understand a concept, try to think of the concept or the problem or the solution in the commercial sense. You can actually build something today that's like mind-blowing, but if there is no commercial use case for it, it may not even see the light of the day, although how much ever awesome it may look like. So as you would be the next generation engineers, I would probably want you to take that thought with you. Any solution that you're trying to build, think about how would people use it, or how easy for people to adopt it. Like you can build something that's 1 crore and not many people would use it. Like you have to build something that's more accessible to many people. So that's important thought to take it forward, and try to keep up with what's happening in the industry. There are, like I showed you some of these standards, especially in the 5G space, that will help you understand what's happening in the industry and know the raw material. Like what I mean by raw material is don't just try to know the surface level details, try to know the underlying building block details. So when you know the building blocks, you have more control over how you play with them. Rather than if you just know the surface level, you keep adding more layers on the surface, although there may be more efficiencies that can be done at the building block level. So those are few thoughts to take it forward. With that, I think I'll conclude. Hopefully this session was useful, and I'll take any questions if you have them.
Thank you, sir. Dear students, faculties, do you have any questions regarding the topic, today's topic? You can also unmute yourself and you can ask directly to the Sandeep sir, or you can also send an email chat box so that we can clear your answers.
So meanwhile, they're preparing answers. So hello, students. Good afternoon to India. So Sandeep, thank you so much for your time and efforts, and for actually the intention is so students, I really need to share the serious efforts of Sandeep here, because he is sitting in the San Diego, California, and it is actually the 11:30 p.m. I think almost 12 midnight now. So the intention is actually you are learning about emerging technologies and automation, PLC, and these things.
Can you please explain the security features of 5G when compared to 4G, sir?
Okay, let's take the student question, then I'll address later. Yeah, so please repeat the question.
I think I understand the question. What are the security features of 5G in compared to 4G?
4G, sir.
So security is a big beast of its own. So by default, like if you compare security of, let's say, any communication technology, be it LTE, be it you can call the cellular technology as one vertical, and then Wi-Fi or Bluetooth as the other vertical. By default, having a SIM make the communication more secure compared to other communication technologies, because the SIM would only enable certain devices to authenticate. But with 5G, you have bunch of layers, because right now you don't have you have more centralized control over the security policies and device onboarding and authentication because of cloudification of the network. It kind of brings in little additional types of security features, but there is nothing specific as in 5G security. Like people call it 5G security, but it's still the same layers being implemented in different parts of the time. But 5G security is kind of the key topic of discussion in release 17 and 18. So you may see some specific techniques that might come about, but right now, as of now, there is nothing specifically associated with 5G in terms of security. But like I said, by default, cellular has security advantages because you have the SIM-based authentication, or onboarding, or policy exchange happening.
Great, thanks Sandeep for interacting with our students today. So students, actually, if you have any further questions, so please feel free to type also in the chat box. So once again, thank you. And I also want to repeat the intention of the students. So students, you are learning this additional emerging technologies in the classroom and the colleges. And our intention is to bring the experts from the different corners of the world to share the different topics with you. And also I should really appreciate, and also I should recall, me and Sandeep studied in the same institutes. And so he's sitting in the USA and I'm sitting in the Europe. So one more intention is, so whatever the small college or a village or small affiliated college or whatever may be, so you can actually, really can become an expert. So the live example is Sandeep in front of us. So he's a 5G expert, where the India is now taking the tiny steps in the 5G. So our central government and our different companies are actually spending the millions of dollars and getting this kind of infrastructure to implement in our country. So as you are learning the topics, and it is also important for you to have a awareness what kind of technologies and what kind of knowledge you are learning. So this is a reason in today's session, and I really thankful to Sandeep. I mean, he added a very humorous examples also. He taken the technology topics and he tried to add the humorous example technology topics and what is applications. Even being a mechanical engineer, I able to understand what communication systems are really important, and also what is the space automotive sector is really improving. So this is the reason whatever your mechanical, your EC or EEE, at the end of the day, your job is going to multidisciplinary engineering. And also thanks to the online platform, actually I am sitting in the airport lounge and I'm able to connect with you, and Sandeep is sitting in US and they're able to connect with me, and thanks to the colleges and faculties also. So this was the intention of this Saturday's expert connect with you people. So students, whatever you are learning, apart from your bookish knowledge, whatever you're learning through this internship, this industry connect is going to create awareness to drive you to the what are the technologies you are going to focus. So this is the reason actually even the state government is funding this activity, and we are doing the activity and we are spending the time with you. So once again, thank you, Sandeep. I mean, in odd hour, I know it is Adrat 12. So I'm very happy you are able to share some knowledge, and also very basic step from the definition until the application. You are able to share the students. So students, as we also have a subtopic as a career connect, and we are very happy to inform you that whatever in these emerging fields, if you want to connect towards the higher education or employment or internship in the abroad, so we are taking the nominations, and we are going to help you in assisting and supporting in this sector also. I think our team already ran the Google form, send your nominations, and I think our team again sent a message now. So we are also figuring out, we are connecting maybe next career connect and industry expert talk. We try to invite the speaker from the university to guide you how to apply the higher education, or if you go to the job now, how to apply the higher education later. So once again, thank you, Sandeep. So I think I'll also call you personally, and so to show my gratitude. And I'm very happy today you addressed the hundreds of students in AP, and I definitely sure our students going to get a very good opportunity with this thing. So students, don't stop your learning, and this is only the first step we are going to take, and then is your interest and your willingness will be leading to the next step in your life in this kind of emerging technologies. Thank you once again.
Thanks, everyone. Thanks for sitting through the session. Hopefully the session was useful. And do let me know if you have any questions. I'll try to address them if I know them. Thank you, and all the best for your future. Thanks, Raj.
Thank you, sir.
Thanks.
Thank you so much for your time.
Thank you. Bye-bye. Bye, everyone.
Bye, sir.